here I will be explaining the fundamental of electronic theory. But first, I will be explaining some key concepts of electricity. These concepts are the components of voltage, current, and resistance. Further, I will be elaborating on the principle behind most electronic systems and how they work. Following that, I will be taking you through different types of electrical circuit like series, parallel, and series parallel circuits. Guys, don't forget to like, share, and subscribe to my platform. Now, let us take a look into resistance and resistor. Alright? As you know, resistance is the opposition to the flow of electricity. The resistor in the diagram is to limit the flow of the current in the circuit. And further look on, a resistor, which is a component as illustrated in this diagram, is that which limits the amount of current that flows through particular circuits. Alright, so let's say the resistors are used in the circuit to ensure that the amount of current is determined for the right component in the electrical circuit. Resistor value are indicated by their color band on a resistor. Resistor value in the diagram is 4.6 kilo ohm with a tolerance of 10%. An electrical current is a flow of charged particles such as electrons or ion moving through the electrical conductor or space. Now, the electrical current has a potential to do work when it transforms from one form of energy into another. Electrical energy is used to determine rather drive motors, lights, initiate alarm, fans, heating elements in electrical and electronic devices. Looking at this illustration, we have a light bulb and a battery along with a switch, and so current is flowing through the circuit when the switch is closed. Alright, so as illustrated, the electrons flows through the battery and by the switch through the lamp. Next, let's look at a simple circuit with a voltage being applied. Right? So voltage is nothing more than what is driving the current through the circuit, and that is determined by our battery in that circuit. Now, what does a voltage means? So voltage represents the source of electricity and the force that drives the current in an electrical circuit. Voltage is also called EMF, an acronym for electromotive force. The symbol that is used to represent voltage is V or E. EMF or electromotive force, otherwise called voltage. These terms can be used alternatively, mean the same. So the EMF is that force that represents that voltage that drives electrons throughout a circuit. The diagram shown in this illustration represents the EMF that is pushing the current throughout the circuit. Let's talk about a relationship between current, voltage, and resistance. The Ohm's law triangle is a relationship between current, voltage, and resistance. Based on the variable to find, you will consider the known in the formula in the triangle, which means somewhat if we need to determine V, we will consider I and R times R in the triangle. And if we need to find the unknown I, then we shall determine V divided by R. And if we should determine R, we'll simply use V and I, right, to determine R. And as the triangle shows you, V is over I and R. So based upon the arrangement, we can understand what does that mean. So R in this case is V divided by I. Next thing we're going to look at is a power wheel and what does it serve. Alright, this wheel is determined from Ohm's law as it is indicated. So what is power? Right? So we talk about three elements or components of electricity: voltage, current, and resistance. But we haven't speak much about the next one, which is power, which is also vital and important to electricity. So power in an electrical circuit is consumed in the form of heat known as IR squared plus. Electric power is the rate at which electrical energy is transferred by electric circuit. SI unit of power is watt, or 1 joules per second. By lowering the power consumed, this means we reduce resistance and current. Let's look at a simple circuit. The first diagram of an electrical circuit in this representation is a series circuit. So within a series circuit, it ensured a closed path for the current to flow without any deviation from that path. R1 and R2 will see the same amount of current. In this circuit, a 12 volts battery is used to drive current around the circuit. So let us look at calculating current, voltage, and resistance in series circuit. Resistance in series circuit is determined by the sum of the resistance within that circuit. Within this circuit, we have R1 and R2. R1 of 5 and R2 of 5. So total resistance would be voltage within the series circuit is the sum of voltage drop across each resistor, R1 and R2, right? And that will be equal to the total voltage. So Vt is equal to V1 plus V2, and V1 represents R1 and V2 represents R2. Now let's cut the current in the series circuit. As you see, the current does not branch off, it goes through one loop. So whatever current goes through the source or fed by the source is also gonna go through each resistors. So what goes through R1, represented by I1, what goes through R2, which is represented by I2. Alright, so let's look at calculating current, voltage, and resistance in a parallel circuit. So in finding the resistance within a parallel circuit, you simply need to take the reciprocal of RT over 1 over R1 plus 1 over R2. And in determining voltage in a parallel circuit, we will understand that the total supplied by the source is going to be equivalent to that across each branch within that circuit. So in this case, V1 would equal to V1A and V1B. The voltage is always going to be equal across each terminal. Current in parallel circuit, however, would be divided by the branch. So the total current that is supplied by the source, in this case, we would say IT, must be equal to I1 plus I2 of each branch within the circuit. Now let's look at a combination circuit, which we call a series parallel circuit. In a series parallel circuit, as it is, we have parallel section and a series section. So in this section, as you can see, R1 make up the series part of the circuit, and then it branches out, divide into R2 and R3, right? So the source is supplied, the current will be divided as it reaches the branch of R2 and R3. So the total current will be flowing through R1, then it's going to be divided between R2 and R3. Now let's look at a series parallel circuit. So in this series parallel circuit, we're going to look at the total resistance within the circuit and how we go about finding it. So RT is equal to R1 plus the reciprocal of R2 plus R3. Solution for RT in the series parallel circuit is determined how the current travels through in a single path before divided into two or more paths. So IT is equal to IR2 plus IR3. Alright, so the current is divided among each branch within the circuit. Let's look at a series parallel calculation. So calculating the voltage and current in a series parallel circuit is achieved by taking into consideration the voltage and current application as well as how they are divided. For example, the current that is supplied by the source, which I call IT, is equal to I1. However, I1, or that source current, is split between the branch circuit of R1 or R2 and R3. So those two as a sum represents the current that's supplied by the source. Let's look at the voltage. However, the voltage is divided within this circuit between the parallel section and the series section. So voltage is equal to V1 plus V2. So that 12 voltage is going to be shared among the resistance in series and resistance in parallel. So VP, which is a parallel section of the voltage, would be V1A and V1B. Okay guys, thank you, and remember to like, share and subscribe. Hopefully see you in another one.